evaluate addition and subtraction expressions. Very, very similar to what you did yesterday. Yesterday you looked at how to write the expressions. Today we're going to apply them to tables and looking at different relationships, okay? Pretty straightforward. Okay, how many of you have a brother or sister? Okay, 5. Oh my goodness. I have one sister, and I'm 6.5 years older than my sister, and I have a brother, and I'm 8 years older than my brother. But for today, we're going to play a little game of pretend, because the module uses the words mine. So let's pretend my sister is exactly 2 years older than I am, but she's not on the oldest. So sharing a birthday is both fun and annoying. Every year on our birthday, we have a party, which is fun. But she always brags that she is 2 years older than I am, which is annoying. Shown below is a table of our ages starting when I was born. So looking at the table, what patterns do you see? So when I was 0, my sister was 2. When I was 1, my sister was 3. When I was 2, my sister was 4. Oh, every year I did get 1 year older. Yep, and she got 1 year older every year too. Now let's think about that word relationship. My daughter actually, she's in 6th grade. She was doing her homework last night, and she actually had tables like this. And she said, what does that mean, relationship? Well, the relationship between me and my daughter is I'm the mother, she's my daughter. The relationship here in this room, I am your teacher, you are my students. Your relationships with each other, your friends, your students, your peers. So relationship is how two things are connected, okay? So relationships means how is this connected to that? You see the word relationships in science when you're writing your conclusion. The relationship between the boiling point and how much salt you added to your water. So we're talking about relationships, the relationship of this to this. How are they connected? So what is that relationship? What do you notice between my age and my sister's age every single year? And don't always go by the first row, because my daughter got tricked by that yesterday. The first row was that. No. So she was like, oh, that's 1 times 2. That's the relationship. But then when she got here, she's like, wait a minute. The relationship doesn't work there. What was the relationship on my daughter's homework last night? +1. So sometimes you might have to go back because the first relationship that you thought might not be the relationship. So make sure it works in all of the rows. So what is the relationship between the two ages in all of the rows? +2. So it's my age +2. I'm simplifying. So when I was 8, how old was my sister? 10. How did you know? Because she's always 2 years older. So when I was 16, how old was my sister? 18. How did you know? It's always 2 years older. So now we were able to figure that out because my table starts at 4. When I wanted to figure out when I was 8, did I keep my table all the way down to 8 and then go all the way down to 16? No. That's kind of annoying. We don't have to extend the table. What we can do is come up with an expression using the variable y for years. So let's add a row to the table. I believe it's drawn for you on the next page. Page 83, top of page 83. So instead, suppose I'm 45. I don't want to keep extending the table and keep saying what if, what if. So why don't we use the y? So no matter what my age is, what do we keep doing? Adding 2. So when my age is y, my sister's age is my age plus 2. So put that in the table on top of page 83. Any questions on where the y came from? Where the y plus 2 came from? Okay, let's switch it up.
Okay.
My sister was 6. How old am I? When my sister was 6, how old was I? 4. When my sister was 15, how old was I? 13. How did you know? Raise your hand. How'd you know? Because I am always 2 years less than her. If she's always 2 years older than me, I'm always 2 years less than her. So let's take a look at the table on the bottom of page 83. So if my sister's age was G, I don't know where they got G from. Now here's the thing. They used a capital G here. I don't like using capital letters for variables. You won't see that very often, and sometimes capital letters for variables stand for something else. For example, when we write our formula, area equals length times width, we use a capital A for area, but a lowercase for length and a lowercase for width. Volume equals length times width times height. Capital B for volume, but lowercase. So capitals are usually reserved for like sums or quantities, total amounts for formulas. So I don't like to use capital letters as variables. So I'm changing that to a lowercase letter. So if my sister was G, how old would I be? Whether we said she was 15 or 8 or 6. Awesome. G minus 2. So fill that in on that table. Any questions on where that came from? So far, so good?
Yeah.
All right, let's continue. All right. Does anybody collect box tops and bring them in?
No.
My husband's always yelling at me, did you throw that box out? There was a box top on it. And he brings in the box tops to his school. I know our school collects box tops. And apparently Noah and Carter are collecting them for their school too. So Noah and Carter are collecting box tops for their school. They each bring in 1 per day starting on the first day of school. However, Carter's a smart little boy. He had a head start because his aunt sent him 15 box tops before school started. Noah's grandma sent him 10 box tops. And Noah added those to his first day. So they already made the table for you. They put the headings in the first row of the table. And they listed the days of school starting with the first day. Now, how come Noah has 11? Where did that 11 come from? Where did the 11 come from? So the 1 that he was bringing in for the first day plus 10 from Grandma. Exactly. Where did Carter's 16 come from? Where did we get 16 for Carter? Right, 1 that he was bringing in plus the 15 from his aunt. Now each day he brought in 1 more. He didn't get them from his aunt and grandma anymore. He just had 1 more. So the number of box tops on the second day of school, how many?
12.
The next day? All right, fill in your tables. Okay, so now looking at the table, if we let D be the number of days since the new school year began, on day D of school, how many box tops did they each bring in? So if my day equaled 1, what did I have to do to get to 11? Because he had 1 plus 10 from his grandma. So does this make sense? When D was 2, it was 12. 3 plus 10, 4 plus 10. Is that the relationship between the days of school and Noah? Yes. So Noah, no matter how many days of school, he has that many box tops plus 10. So you're writing that in your notes. God bless you. On D days of school, how many box tops will Carter have brought in? What's the formula for Carter? Right. Ahem. So now on day 10 of school, how many box tops will Noah have brought in? So if my day equals 10, the first thing that I'm going to do is write the formula. This is very important, and this is what I expect to see on a test or a quiz. So my formula for Noah is the number of days plus 10. Since my days equals 10, I'm going to replace the D with 10. So 10 plus 10 is 20. So Noah has 20 box tops. So formula, plug it, solve it, label it. Now we're looking at Carter. Carter's formula was the number of days plus 15. And over here they're telling me that my day is 10. So 10 plus 15 is 25. So Carter will have 25 box tops. No, where's Waldo work? Top to bottom, formula to answer, FTA, formula to answer. How's that?
That's good.
Thank
Make
you.
a sign for that.
So formula to answer, and then label it. Okay? Ready?
Yes.
Next example, next real world example. Each week, the primary school recycles 200 pounds of paper. The intermediate school also recycles the same amount, but had another 300 left over from summer school. The intermediate school custodian added this extra 300 pounds to the first recycle week. So the table is set up. We have the number of weeks. We have the primary school. And look how they also include the unit. The unit is included in the heading on your tables. So now let's label the weeks of school. So how many did the primary have the first week? All right, and then each week we added 200 more. Questions on any of those? Each week the primary school collected another 200 pounds. Should be 1, X plus 1. All right, so what do we have for the first week in the intermediate school?
300.
Yeah? 300? I see some hands going up. Lauren? Lauren says it's 500. Ah, got a little debate here. Is it 300? Is it 500? I don't know, maybe it's 200. It says they collect 200 pounds per week. Where are these numbers coming from? What's the answer? Do you think it's 200? Raise your hand. It's 200 per week. All right, nobody's raising their hand, so I'll erase it. If you think it's 300, raise your hand. I got one hand up.
No, that's not Frankie's.
No? All right, so 500? And a few chickens not voting. All right. Why is it 500? Why is it? A lot of people jump right to that 300. Why? Right, so they added this extra 300 only to the first week. So the first week was 500, the 200 that they recycled, plus the 300 from summer school. So how much was week 2? 1,000? No, how much? You wanted to say 1,000. No, what do you want to say? 400? So each week they collected another 200 pounds. Right. Right, fill in your table. All right, now, if this trend continues, what will be the total amount collected on week 10? Now, let's be careful. Anybody want to make a prediction? In fact, what I'm going to do is write our prediction in yellow. So what is our prediction for week 10 for the primary school?
2,000.
What is our prediction for the intermediate school? All right, let's see if they're correct. What'd you both do? Double it from week 5? You both doubled it from week 5? Let's see what happens. So, over here we have the primary school. Gentlemen, there are about to be consequences for your behavior. I've warned you and I've asked you nicely. So you said you didn't double it. How did you come up with your answer for the primary school?
Because the primary school is getting 200 pages of recycling 200 pounds of paper a week.
200 pounds per week. How can I write that as an expression? So you took the number of weeks and multiplied it by 200?
Yeah.
So you did weeks times 200. So what would the formula be? What's the right way to write that formula? How should we write that? Right. So our formula is going to be 200W. And what do we know? We know that my weeks equals 10. So wherever I see W, I'm going to replace it with 10. So multiply 2,000 pounds of paper. Formula to labeled answer. Formula to labeled answer. All the way down. Whoops, would you like the R on paper? It looks like Pope. 2,000 pounds of Pope. It's a big Pope!
Oh.
The Pope, the big Catholic man?
Oh.
Yeah. Not that big, not 2,000 pounds big, but okay. Now, for the intermediate school. The intermediate school also does 200 pounds per week, plus they had another 300, but that was only the first week. So what kind of a formula could we come up with for the intermediate school?
300W.
So did we take the weeks and multiply it by 300? So 3 times 300. Oh, that one worked. All right, so 4 times 300. Did that work? No. So it's not the weeks times 300 because 1 times 300 is not 500. What is it? Let's take a look at what we wrote here. How do I write 200 pounds per week as a formula?
200W.
Right, 200 times the number of weeks. But I also have to add that plus that 300. And let's see if that makes sense. 1 times 200 is 200 plus 300 is 500, girls. 2 times 200 is 400 plus 300 is 700. So it works. But now we want to find out when it's week 10. So 200 pounds times 10 weeks plus the 300 pounds from week 1. We follow our PEMDAS laws. 2,000 plus 300, 2,300 pounds of paper. Were our predictions correct? I'm going to give you a second to write it down. Let's take a look. Here we said 2,000. Did we say 2,000?
Yeah.
Yep, so that was correct. What about here? Was our prediction correct? Okay, thank you. How come our prediction was wrong for the intermediate school? How come our prediction was wrong for the intermediate school, Frankie?
Because instead of doing we doubled it.
We doubled it, but it's not double the amount because we started with an extra 300. So that's why the formulas come in handy. So it's not 2,600, it's 2,300. Okay? That one was challenging. The intermediate one was definitely more challenging than anything else we're going to see today. But good, you did a good job with it. All right, so number 3. I feel like I'm missing a page. Now next on yours, number 3. All right, so Shelly and Kristen share a birthday, but Shelly is 5 years older. Make a table showing their ages every year, beginning when Kristen was born. So our top row is going to be our heading. So we have Kristen, age, and remember you want to label your unit. So, please open your binder, take your notes. Always try to label your unit in your heading on your columns, in your first row, okay? So, when Kristen was 0, Shelly was, when Kristen was 1, Shelly was, when Kristen was 2, Shelly was, when Kristen was 3, and Shelly was, because she's always 5 years older. So we're always taking Kristen's age and adding 5. So no matter what age she is, we can figure that out by putting it in the table. So if Kristen is K years old, how old is Shelly? Right. So if we know Shelly's age, if Shelly is S, how am I going to figure out Kristen's age? If Shelly is 10, how old is Kristen? 5. So what would the formula be? Right. So your variable could be in either column, and sometimes you could add or sometimes you could subtract. So if you're adding the relationship one way, you're going to be subtracting the relationship the other way. So you could add those two columns onto your chart, okay? And they did ask it here. All right?